Welcome to Chapter 8. We're going to talk about the rules for exponents. There's 5 rules for us to go over. In the first rule, it deals when you have a 0 power. And just to make sure, a quick review, exponents and powers are the same thing. So I use those two words interchangeably throughout the lecture. All right, a 0 power. Anything to a 0 power is equal to 1. Right. And a couple examples. If you had 5 to the 0 power, that is equal to 1. Right? This is not the same thing as 5 times 0. 5 times 0 is 0. But 5 raised to the power of 0 is equal to 1. Right? This is true for fractions. 1/4 to the 0 power is equal to 1. It's true for variables. X to the 0 power is 1. It's true for negative numbers. -3 to the 0 power is equal to 1. You can also mix it in with other numbers. So for example, 5ab to the 0 power. In this example, the only thing raised to the 0 power is the b. The 5 and the a, they do not change. So this is 5a. b to the 0 is equal to 1, which is just simply 5a. So those are all examples of something raised to the 0 power. All right, our next rule deals with negative exponents. For negative exponents, you need to make it positive. So to make positive, you are going to take the reciprocal of the number. All right, so let me show you what I mean by that. For an example, if I had 5 to the -2 power, that's my negative power, I can rewrite 5 as 5/1. So to make this a positive, I'm going to move the 5 to the denominator, or think of the reciprocal 5/1 as 1/5. The 2 tags along with the 5, but it's no longer negative, it's now positive. And I know that 5 squared is 25, and that is my final answer. Okay, let's look at another example. If I had, let's do 3x to the -2, right? And remember, if there's no number in the denominator, it's just over 1. All right, the only thing raised to the negative power is the x. So the only thing I take the reciprocal of, or move to the denominator, is the x squared. So this answer becomes 3 over x squared. The 2 tags along, and it now becomes positive. And the 1 moved to the top. 3 times 1 is simply 1, so my answer is 3 over x squared. Okay, and let's do one more example. Let's do 4 over 3 x to the -5. All right, once again, I'm going to identify the one part that's associated with the negative exponent. So this is the same thing as 1 over x. I'm going to take the reciprocal, Move the 1 down and the x to the top. So I get 4, it doesn't move, x to the 5th over 3 times 1, which is just 3. And that is your final answer. All right, for rule number 3, what happens when we multiply like bases? We are going to add the exponents. Okay, and let's do a couple examples to show what I mean by that. If I had 5 squared times 5 to the 4th, if I want to simplify this, I take my common base, which is 5, and I'm going to add the two exponents, 2 plus 4, and I get 5 to the 6th. And if you want to, you could type that in the calculator and get the number. Okay, so let me lay it out in the next example. So if you're more of a visual learner, you can see how it all falls together. Let's do b cubed times b squared. So I know by my rule of exponents, I would add those. B to the 3 plus 2. And my final answer would be b to the 5th. But why is that? All right, I'm going to go back to the definition of an exponent. It means that you take that letter or number and you multiply it 3 times. So b cubed is b times b times b, which means b squared is b times b. And I'm multiplying those together. So ultimately, I have 1, 2, 3, 4, 5, which is b to the 5th. Okay, the rule of exponents, for multiplying exponents, it just helps to shorten the problem up a little. All right, and rule number 4, divide like bases. We subtract the exponents. All right, so let's do just a couple examples for that. If I had x to the 4th over x cubed, if I want to simplify this, I have 4 x's on top, 3 x's on bottom. I subtract the 2 powers, and I simply end up with x to the 1st, which is just x. And so again, if you're a visual learner, I can write this out. There's my x to the 4th. Here's x cubed. You can reduce by canceling 3 of them, which leaves you with just x in the numerator. Okay, let's do one example, one more for subtraction. What if I had b squared over b to the 5th? I have 5 b's on the bottom and 2 b's on top. Right? I'm going to do b to the 2 minus 5, which is negative 3. And remember, you can't leave a negative in your problem, so that's b over 1. Do the reciprocal, and I get 1 over b cubed, which makes sense. If I had 5 on bottom, I canceled the 2 from the top. That would leave me with 3 in the denominator. Okay, and I have one more rule to go. What happens when you raise an exponent to a power, or a power to a power? We are going to multiply the exponents. Okay, so let's just do a couple examples of those. Let's say we had r squared to the 5th power. Right, so this is the same thing as saying r squared 5 different times. There's 2, 3, 4, 5. So remember, you add 2, 4, 6, 8, 10, which leaves me with r to the 10th. If I use my power to a power rule, it shortens it up a little bit. I would take r to the 2 times 5, which is r to the 10th. And then you don't have to write it out every time. All right, and one more example. What if I had 3 times x squared cubed? All right, the only thing being raised to a power is this x squared. So I'm going to circle it. That's what I'm going to multiply. The 3 doesn't change. So here I have x to the 2 times 3, or 3x to the 6th. And that would be my final answer. And that is a quick sum up of the 5 rules using exponents. If you have any questions on them, just look back at any one of the examples.